A very good morning to one and all. I welcome you all for this session number 27. In this session, we will learn about D'Alembert's principle. Let's recap of what we have studied in previous classes. In previous class, we learned about generalized displacement, generalized velocity, and generalized force. The generalized displacement is given by delta Ri is equal to summation I is equal to 1 to n dou Ri by dou Qj into delta Qj. Whereas generalized velocity is given by Ri dot is equal to summation of I is equal to 1 to n dou Ri by dou Qj into dou Qj dot plus dou Ri by dou T. Likewise, generalized force is given by Qj is equal to summation J is equal to 1 to n Fi dou Ri by dou Qj. Now in this session, we will learn about D'Alembert's principle. So by the end of this session, we will learn about D'Alembert's principle. So in the previous session, we learned about virtual displacement and virtual work. Virtual displacement is defined for a body which is at rest or the body is in static state. However, for generalized motion, we use D'Alembert's principle. We know that according to Newton's second law of motion, Fi is equal to dP by dt, or Fi is equal to Pi dot. Rearranging terms, it becomes Fi minus Pi dot is equal to 0, which means the force acting on the ith particle of a system minus reversed effective force will be equal to 0. We know that the force acting on the ith particle of a system is equal to applied force plus force of a constraints. Since the constraint forces have virtual displacement, consequently virtual work will be 0. Taking into consideration that work done by the virtual displacement is equal to 0, the ith force, a force acting on the ith particle, will be equal to the external applied force. Then Fi dot A, which is an applied external force, minus Pi dot into generalized displacement is equal to 0. You have seen the applied external force minus reverse effective force, the total force is 0. So summation of I is equal to 1 to n Fia minus Pi dot into delta Ri is equal to 0. This is D'Alembert's principle mathematically. It states that the resultant force acting on a body together with reversed force are in equilibrium. Note that the force of constraint disappears from the problem. So what we have seen, we learned D'Alembert's principle for a generalized motion of a body described in equilibrium by applied force with reversed effective force. They are in equilibrium. Now let's have a small MCQ session. Summation I is equal to 1 to n Fia minus Pi dot into delta Ri is equal to 0. This is an expression for D'Alembert's principle. So option is C. Question number 2. Fia term is, this is the first term, which is the applied external force. So answer option is B. Question number 3. Pi dot term is, it is a reversed force, so it is known as reaction force. So the answer is kinetic reaction. Question number 5. Delta Ri term is a displacement. In D'Alembert's principle, work done by the constraint force is equal to, it is 0. Question number 7. Force acting on the ith particle is equal to, we have seen, it is the sum of external force and force of a constraint. So the option is A. Question number 8. Fi term is a constraint forces. Question number 9. The resultant of the applied force and kinetic reaction for an equilibrium condition is, it should be 0. Question number 10. This expression implies a dynamical system appears to be in, it is static. So in this session we learned D'Alembert's principle. Hope you all enjoyed this session. Thank you one and all.